Hi there, and so this is a project demo for my ENEL351 Lab 2 here. So the first part of the lab is that we had to make the onboard user LED turn on for 1 second when we press the user switch. So we just had to go and modify this function here to do that. And so we can go and load. There we go. So we go and press reset and press the user button. Turns on. Pretty simple stuff. Now on to the second part of the lab. So in the second part of the lab, we had to make these 4 LEDs come on according to these buttons. So in my case, I just kept it simple. The bottom LED comes on when the blue one goes, green one, the one next to it, blah, blah, blah. Black one is the topmost one there. So pretty simple. Before I get into the demo there, I'm just going to talk a bit about my code here. So we can see, I just have to scroll up to the top of the code here. So you can see every time when we want to do something in C with this microcontroller, you have to go and modify the registers, doing stuff like this, which is very tedious and time consuming and stuff. So I created various Arduino-like functions for my STM board here. So we got pin mode first of all, which just configures general I/O here. And so we can see I made this custom table of 42 I/O pins and map them to just a number, so that makes things a little easier for later. And this, of course, takes into account any hardware conflicts that are potentially on the board we're using, such as PA2 and 3. By default, their solder bridges are left open because they're really only meant to be used as a UART connection and not as general I/O. PA, where is it? So you have PA 13 and 14, they're used as the programming lines for when you want to put a new program on here. And then we can see we only go up to PC 13 here because 14 and 15, they're used for something I don't remember. And then PD0 and PD1, those are used for the 32 kilohertz clock crystal for the RTC. So you can't use those as general I/O. I also made this handy little table here showing where all my numbers map to on the Morpho headers, as well as the Arduino header that's provided on the board here. So that'll be handy for later. So then we'll actually get into the function here. So then, of course, mode as well, you have to tell what you want to configure the pin for. So got, general purpose push-pull, general purpose open collector, alternate function output, push-pull, blah, 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 and then your inputs, analog, digital floating, digital pull down, and digital pull up, which I will demonstrate the pull down in a bit. So then we can see here, it takes, of course, the pin argument and the mode argument, and it doesn't return anything. And so then, blah, 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 lots of stuff here. As you see, it's a very long function, very big function, because there's over 336 combinations, because 8 times 42 is 336. So we just scroll here, you see it's hundreds of lines of code. We're only at pin 15 here, so that's fun. So just keep scrolling. Lots and lots of copying and pasting and making little changes here and there. Line 1200 something, 1300, 1400, 15. Where are we at here? Pin 31, we're getting closer. 1700, 1800, 1900, 2000, pin 39, pin 40, 41. There we go. So so I wrote that for pin mode. Then of course we needed a digital read function, which of course just takes a pin and gives you the value at that pin. So that's fun. Lots of shifting stuff here. This is a shorter one of the functions I had to create. Doesn't need that much code. Then of course we have a digital write. So of course that takes pin and state, and then of course it sets pin as on or off depending on the state that you give it. I messed this up the first time and I ended up having my LEDs just stay stuck on. So this one's a little bit of a longer function too here. So over 3,000 lines of code so far in my SAM util.c function. So that was fun. Took many hours to write this. So now util.h. So one other little feature I added was, so there's 8 different values for mode that can be sent, but I don't want the user to have to remember what a 0, 1, or 2, or 3 to 7 is. So I made a little enumerated thing here. So output push pull, output open collector, output or alternate function push pull, alternate function open collector, input analog, input digital floating, input digital pull down, and input digital pull up. So that'll be handy for later. So now we can get into the main program. So main.c here. So include stuff, clock initialize, then we declare our buttons and LEDs here according to my custom scheme that I made for I/O. Then got your pin modes here, and then we get into the main loop, which just does some reads and some writes. So pretty simple stuff here. So we can go and flash the board. As you see, it takes quite a while because these functions are fairly large, but it does say loaded. So it's kind of one weird bug that I haven't figured out what's going on with this. When I press the reset button, it should execute the code, but none of my buttons do anything. So I did figure out a little trick though. So if I go into the debugger and we step through stuff, okay, we just want to step out of the clock init function here. There we go. Step over. So declare stuff here. It's declaring things. And then it does our pin modes. And then now that it's in, well, now that it had gotten to the main function, it should now work correctly. So we disconnect our debug session. And now, there we go. Press the bottom button. It turns on the first LED, second LED, and fourth LED. So that's pretty simple. But one thing I find messy about this is that we're using a 10K bus resistor network here to pull up our switches. Well, I would like to be able to use the internal pull down resistors and have these switches just connect to 3 volts. So I'll just pause the video here and make some modifications to the code to do that. Okay, so I made some modifications here. So as you can see, I took away the bus resistor network and just have the switches so that they connect the pins to 3.3 volts now. So a lot cleaner there. And then to make that compatible with work though, so I go through here, so buttons of course that doesn't change, but you can see here the parameter I gave the pin mode now is in digital pull down. So that way, the pin doesn't sit there floating randomly. And then of course the LEDs are the same. And then of course I simplified my digital or my main loop here. So we no longer need that read variable. Instead, we can call digital write, but then give the digital read as the second parameter here to read the button. So a lot cleaner. So now of course, we can load the program. Go. And we still have that weird bug with my board. So if I reset, it doesn't do anything. But we can go through the debugger and make it do things. So step, do its thing with initialization. So then we're here. step over, blah, blah, blah. I think we should be able to step out of the debugger here and have it work properly. So let's see. Yeah, there we go. So I'm not sure what's going on there with the, but if I do the debugger, it does work. Yeah, so that is one LED lighting up. There we go, that's a little better angle. So again, it works just like it did a few minutes ago, but now it's a lot cleaner looking without that bus resistor network there. So yeah, that is my demonstration of my ENEL351 Lab 2 there.